go to the second test of mean difference is the PET sample t-test. We move to the second test of the mean difference in the group of the parametric is the PET sample test. The PET sample t-test or match sample t-test or related sample t-test is a test to find the difference of the two samples that are dependent or related. It is used when the data is from only one group of samples with 2 times the measurement. Studies which employ a pre-test and a post-test design may consider the PET sample t-test for the analysis. In the pre-test and the post-test design, we measure the same variable twice or maybe at the 2 different time points, and we are interested in whether this measure has changed in the duration. In addition, we may also have a separate groups, but they have been pairwise matched in some way. This is also an example of PET sample t-test data. The most important part in the PET sample t-test is normally distributed data because this is under parametric test. An example of research design that can employ PET sample t-test is a single-arm pre- and post-test study design are displayed. The next slide. At the left-hand side here is a figure for an example of the research design that can employ PET sample t-test, single-arm pre-test score, and the post-test score. Right, so we make it a comparison, pre-test and the post-test, and between the pre and the post-test, we have the intervention. So according to this figure, we can come up the research question for the single-arm pre and post-test. There are 2 research questions. The first one is there any significant increase from pre-test to post-test score among the students after remedial class? And the second one, is there any change in the thickness or arterial plaque before and after treatment with the vitamin E? Before we further to make it a PET sample t-test analysis, we need to look at the assumptions of the PET sample t-test. There are 4 main assumptions needs to be complied before proceeding with the analysis of the PET t-test. The first one is there are 2 test variables and it is numerical or continuous. So means that your variable must in a group of continuous or numerical. So the data is gathered at random. The observation or measurement are dependent or PET or match. And the last assumption, the difference between PET data must be normally distributed. So here is a data requirement. Since the PET t-test is measuring the 2 points of dependent data, there is no independent variable. So means that you need to remember that when we apply the PET sample test, we just measuring the 2 points of dependent data. There is no independent variable in the PET sample test. The 2 variables to be tested must be numerical or continuous only. So here we have the syntax. We have the coding for the R, alright, starting from the library and also data 1. So you just use the syntax for the PET sample t-test, and here is the output based on the syntax given. Alright, after we call the data, we need to make it the research question, the hypothesis, and also the most important part is we need to checking the assumption, right? So this is the research question that we create based on the data, right, and also the hypothesis. All right, so the next one, we need to check the assumption. The first assumption that we need to check is checking normality of the difference between before and after intervention. Right, so this is a syntax. The first one is creating the new variable, is a different before and after, and also next one, we need to perform Lilliefors test. This is the first result in the group of the assumptions of the normality is the Lilliefors or Kolmogorov normality test. All right, so this is the output here, and then we need to interpret your result. Right, so we need to interpret the result based on the statistical test for the normality distribution using Lilliefors test. It was found that the different BMI between before and after intervention was normally distributed. Why we say the normally distributed? Since the p-value of the Lilliefors was more than 0.05. Right, you can see that the p-value given is 0.2392 with the D statistic is 0.0917. We also can check by graphical presentation, either the box plot, histogram, scatter plot, and so on, right? So here is a syntax of the ggplot, right? So ggplot for the box plot, here, ggplot. So here is a syntax. We call the syntax for the ggplot, and then we have the output. This is the box and whiskers plot, right? So the distribution of difference between BMI before and after intervention. So we need to interpret the result based on the box plot. It is clearly seen that the difference between BMI before and after was normally distributed. After all the assumptions of the normality is met, we can move to the performing PET sample t-test. To perform PET sample t-test, we use the same function as in independent sample t-test, which is function t.test function. But we will add another argument inside the function, which is PET is equal to true. So this is a function for the performing PET sample t-test, the syntax for the PET sample t-test. So here is the continuous with the independent sample t-test, t.test function, but the difference in the PET sample t-test, you need to put PET is equal to true. So here we have the output for the PET sample t-test, and next we need to interpret the result. So based on the result here, we can conclude that there are significant difference on mean BMI before and after intervention since the p-value was less than 0.05. So where the value of 0.05 is here, right? So this is the output for the p-value, right? So p-value is less than 0.05 with the t statistic is 7.4, 724, and with the degree of freedom is the 59. So furthermore, we can compare the effectiveness of the intervention by mean and also the standard deviation. We also can come up the value of the mean, the value of the standard deviation. So this is the syntax for the mean as apply, and then so at the last side here is we put the mean syntax. So also the same one is the standard deviation. The keyword or the coding for the standard deviation is the SD. So we have the output for the mean and also the standard deviation. So we can interpret the result. So we can conclude that the mean BMI after, right? So this is the mean BMI pre and also the post test. Look at the output here. We have the pre and the post test, and here is the difference between before and after. Okay, all right, we can conclude that the mean BMI after, right, so mean and also the standard deviation intervention was improved compared to before mean and standard deviation intervention. Here is the reporting PET sample t-test result. After you run your data, after you use the syntax, the R syntax, you can get the output, and then you need to come up based on your reporting, based on your reporting PET sample t-test table. Alright, so based on the table 3, this is the output for the comparisons of the body mass index BMI before and after intervention with the n is equal to 60. So in the table 3, we have the variable, we have the mean before, mean and also the standard deviation. After mean and the standard deviation, the t statistic, the degree of freedom, and also the mean difference, and last one is the p-value. Right? So the next one, we need to interpret the result based on the table number 3. So the table displays the result of a PET sample t-test comparing body mass index BMI value before and after an intervention for a sample of 60. Right? N is equal to 60, and another interpretation based on the first one is a mean before intervention. Right? So you can interpret the details about the mean before intervention. Alright, so this is the first one. You explain in details about the mean BMI before intervention. The second one, you can discuss about the mean BMI after intervention. You can discuss mean BMI after intervention. You can discuss about the degree of freedom. You can discuss the mean difference. Alright, each result in the table 3, you need to report one by one. Next one, you need to discuss about the p-value, and the last one, you need to discuss about the assumptions of the PET sample test, assumptions of the study. Right? So in summary, in the table 3 suggests that the intervention was effective in reducing BMI among the participants, with the reduction being statistically significant. Why we say the statistically significant? Based on the last part or the last value, p-value.